Okay, the question is sketch the graph of y is equal to tangent x for x greater equal to 0 to 360. Mean from 0 to 360 degree, you have to sketch the graph for y is equal to tangent x. The graph of sine and cosine is different than the graph of tangent. For tangent, we have asymptotes also. I'm using a word asymptote. What is the meaning of asymptote? Asymptote is a line to which the curve will never touch. If you have to check at which value the tangent has asymptote, for example, look, the values that you will take is 0, 90, 180, 270, 360. Mean from 0 to 360. If you take your calculator and check with the calculator, you will see if you take, for example, tangent 0, it will give you 0 value. It means at this value at 0 degree, tangent can be defined. Okay. If you take tangent 90, it will give you math error. When it gives math error, it means its value is infinite. It means at this value of theta, tangent cannot be defined. So this value of theta will be an asymptote for tangent. It means the first asymptote for the tangent is 90 degree. Now check for 180 degree. Tangent 180 degree. Value is 0. It means at this it is not an asymptote. Check tangent 270. Math error, it means 270 is also an asymptote for tangent. So 270 is also an asymptote. Okay. Then check with 360, tangent 360. At 360, the value is also 0. It means it is not an asymptote. So from 0 to 360, these two values are the asymptotes. Mean these are the angles where the graph will not cross them, will not touch them. So how we will show the asymptote here? The way to show the asymptote is make the dotted lines. For example, make a dotted line through this one. You draw this asymptote. At 270, there is the second asymptote. So make a dotted line like that one. Then from 0 to 90, the graph of the tangent will be, if we draw that one, the graph of the tangent in this situation will remain, you can check, it will remain above y-axis and the shape will look like this one. As it will get near to the asymptote, get closer and closer, but will never touch it. Till infinity it will go. Now from 90 to 180, from 90 to 180, it will be like this. It will be below the x-axis. And from 180 to 270, it will be like this one. This is the graph of tangent. Okay. Similarly, now again, from 270 to 360, if you will draw the graph, so it will keep repeating its value. That will be below the x-axis. It will be like this one. This is a graph of the tangent. Now, if you next have like from 360 onward, so then again, the next asymptote will be after, if you add 90 more in 360, so it will be next asymptote for that one. But usually, we have to deal in IGCSE with the graph from 0 to 360. So this will be the graph for tangent x. Okay. So you have to remember that, don't forget it, please. Second part is saying, solve the equation for this equation you have to solve. No, the way to solve the equation for all trigonometric ratios will be same. What you have to do, first you have to separate the trigonometric ratio. What it will make? It will become tangent of x will be equal to, when you will take the 5 to the other side, it will divide. Once you take that, then what you have to do, because from 0 to 360, it will have more than one values actually. You can see here, even there are two values of x that has been asked. So what you need to do for that, you need to take the reference angle. Okay, find the reference angle. What is the way to find the reference angle? Reference angle, for example, if you have tangent here, it will be tangent inverse of the value, but positive value. If it is even negative, you will take it positive. If you have, for example, sine here, you will take sine inverse the value of the sine. If it is cosine, so cosine inverse. So that will give you the reference angle. Okay. Now, what you will do, find this value here. Find tangent inverse 1 over 5. Shift tangent 1 over 5. It will be 11.309. Okay. 11 point, right here, 11.309. That you can round to 3 significant, so will become 11.3. Okay, this 11.3 is the reference angle now. But what you have to do after finding reference angle, let's take this, make the quadrants, and remember the fact tangent is positive in first quadrant and in the third quadrant. These are the two quadrants where tangent is positive. Okay, so as this value is a positive value, so it means you will show the angle here in the first quadrant and in the third quadrant. If, for example, in this case, if tangent will be negative, then I will show it here in the second and in the third quadrant. But remember, these two quadrants, first quadrant and third quadrant, these quadrants are where the tangent is positive. So what I need to do, this angle that we got right now was 11.3 degree. I will say this angle 11.3 degree here and this angle 11.3 degree here. Now the way to write, if you have to find what your angle is x. The way to write in the first quadrant is your angle, because angle here is x. Your angle is equal to reference angle in the first quadrant. Okay, so as it means if you are taking this value, it will be just 11.3 degree. But the way to write in the third quadrant is the angle will be in the third quadrant 180 minus reference angle. This is the way to write. So it will be 180 minus 11.3. So if you will subtract from 180 11.3, you will get 168.7. So it will be 168.7 degree. So 11.3 degree and 168.7 degree. Okay, there are few rules regarding them. If you want, I can just recall here, and I think it's better to recall. Remember, in the first quadrant, all values, sine, cosine, tangent, all are positive. Sine is positive, cosine is positive, even tangent is also positive. But in the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. It means the other are negative here. In the fourth quadrant, only cosine is positive. The other are negative. So as I was having the positive value of tangent here, so that is why I took here and here. And the way to write, for example, if you are taking in the first quadrant, the way to write the angle is just reference angle. In the second quadrant, we write 180 minus reference angle. In the third quadrant, it is 180 plus reference angle. And I'm sorry, I make a mistake here. Actually, this is in the third quadrant, so it should be 180 plus reference angle. So if you will make 180 plus reference angle, really sorry, it will change to, because this is the way to write the angle if it is in the third quadrant. So 180, it should be 180 plus 11.3, so it will be 191.3. It will be 191.3 degrees. So in the fourth quadrant, the way to write the angle is, it will be 360 minus reference angle. This is the way to write in the fourth quadrant. Okay, so these values, remember, whenever we have to solve any equation that has the trigonometric ratios, this one and this one we must have to use. That will be. Next, question number 20, the last question of this paper. This question is saying the distance between the two towns is 600 kilometer, correct to nearest kilometer. It means if it is given correct to the nearest kilometer, immediately the concept of upper bound and lower bound you must recall, because it's given 600 kilometer, correct to nearest 10 kilometer, and a car takes 8 hours 40 minutes, correct to the nearest 10 minutes. Again, the time is also given, so you may need upper bound and lower bound of that also. Okay, so calculate the lower bound of the average speed of the car. Now, what is the formula for the speed? First of all, average speed or speed. The average speed or speed, the formula is total distance divided by time. But in this case, we want the lower bound. And remember, if you have, for example, you have to find the lower bound when you are dividing the two quantities. So what we do, we need the lower bound of the numerator and the upper bound of the denominator. So if you want the lower bound of the speed, what will be the lower bound of speed? It means it will be the lower bound of distance divided by upper bound of time. The complete lesson about the upper bound and lower bound is available on the channel. You can go and watch that one also. So it means I need to take the lower bound of distance here. How I will take the lower bound of distance? How do we take the lower bound? This is the degree of accuracy. Units are same. So how I will take the lower bound of the distance? What we do, this is distance, half the degree of accuracy. Degree of accuracy is 10, half it will become 5. So half of the degree of accuracy you will add in this one. It will become 600. Sorry, for lower bound you have to subtract. For upper bound we add. For lower bound we subtract the half of degree of accuracy. So it will become 600 minus 5 divided by, we need the upper bound of the time. But the problem is here time is in hours and minute, and here the degree of accuracy is in minutes, and we want the unit in kilometer per hour. So that is why you should change the time into completely into hours, and this also into hours. If you take you are having here 8 hours, let me convert the 8 hour 40 minutes into, we are having 8 hours and 40 minutes. Change it into hours. How do we convert that? It will be 8 plus 40 and divided by 60. It will completely now be in the hours. Okay, so what it will become? 8 plus 40 divided by 60. So will be 8.666. That means you can say, you can round it to 8.67. Okay, so that is 8.67 hours. Or let it be in the fraction form. Now change minute also into, if you have the 10 minutes, 10 minutes you have to convert into hour. It will become 10 over 60, which will be 1 over 6. 1 over 6. Then to find the lower upper bound of the time, you have, this is the degree of accuracy. half the degree of accuracy. If you will 1 divided by 6, if you will divide this by 2, that will be its half. Okay. So what is the half of the degree of accuracy? Half of the degree of accuracy is 0.08. Okay. So you have to add 8.67 in this one, because for upper bound we add, plus it will be 8.67. So we will get 8.75. Okay. So that will be the upper bound of this one, 8.75. Let's calculate 595 over 8.75. So get the value 595 divided by 8.75. So we'll get 68 kilometers per hour. That is the lower bound of the average speed. So whenever we divide the two quantity, we want upper bound. So we will take the upper bound of the top one and the lower bound of the denominator. If we want the lower bound of the quantity, so we will take the lower bound of the numerator and upper bound of the denominator. And the way to take the lower bound is half the degree of accuracy, subtract from the value. The way to take the upper bound is half the degree of accuracy and add in the value. But before that, units should be same. So in this case, units were not same. So what I did, I made the unit same. I made this unit into hours, I converted it into hours. Okay, and this was in the minutes, so I converted it into hours. So when I got that one, this is 1/6. This is the degree of accuracy mean. So I halved the degree of accuracy and added in this one. So that become 8.75. So that is the upper bound of the time.